welcome to a great new tutorial. This one, completing the square. So let's dive straight in. There we go, job done.
Well, there's obviously more to it than that, but what actually is completing the square other than just a strange title? Well, let's have a look. Here's the basis of what we're doing. We need to look at the reverse process first so that we can see what the point is. Now if I start off with a bracket squared, like this, and expand it out using the FOIL method. I've said this before, it's up to you how you expand it out. But we'll get an x squared term, we'll get an ax and another ax, and then we'll get an a squared. Or to tidy up, we will get x squared, two lots of ax, add a squared. So we can see when we expand out one bracket squared, the a in the bracket becomes 2a in the expansion. And that is the basis behind the method of completing the square. What we have to do is start off with an expression something like this and put it back into one bracket squared. Now it's not factorizing, it's a different method of manipulating quadratic expressions, and we'll come to some uses a little later on, and also some other methods from a couple of websites and how they'll deal with it as well. So let's just look here. We've got x squared plus 6x plus 9. Now if I'm going to put that into a bracket, notice the 2a here becomes half as much here. So in my bracket I've got to have a 3 and squared. Now that will give me a plus 9 at the end, so this one is a perfect square already, as is x squared, add 10x, add 25. That will go immediately into one bracket squared, as will x squared, take away 12x, add 36. That can be written directly as x take away 6 squared. All of these are examples of perfect squares. Now what you're likely to meet as an expression isn't a perfect square, so that's where the completing part of it comes in. So let's just take another example.
A vast virus database has been updated.
Thanks, love. Let's do some examples to illustrate the method then. Example 1. X squared, add 6x. Now I want to complete the square on this. What that means is we're going to try and force it into one bracket. So we have determined that the number in the bracket is going to be half of the coefficient of x in your starting expression. That gives me x plus 3 squared. Expanding this out, which is just a little bit of an aside, will give you x squared, add 6x, add 9. Our original expression didn't have a plus 9 at the end. So in order to complete this square, this is a square, but it's not what we started with. So to complete it, we have to subtract 9. That's now finished. Second example. X squared, take away 10x, add 7. My bracket starts off being that, and this is always going to be half of the x coefficient in your original expression, including the sign. Expanding this out again, I would get x squared, take away 10x, add 25. I wouldn't necessarily put this step in every time, but I'm explaining things to you. Now this would give us an add 25, and we only want an add 7. So let's take away the 25 to eliminate that, but we need a plus 7. Then we just need to tidy the bit up outside of the bracket. Take away 27, add 7 is the same as taking away 18. So that is now completed. The plus 25 that this brings in from the expansion needs reducing by 18 for it to be the same as our original expression. If you've got the idea, then why not just pause the recording and try this one for yourself, then start it up again and see if it matches the correct answers. I'll do 2 more, this one and example 4. So if you want to pause it. Right, my answer then, comparing it with yours if you're bothered. X add 7, putting the working out in. That will give me x squared add 14, x add 49. So I need to subtract 49 to take account of the 49 that the square bracket has introduced, but I want there to be a plus 10 at the end. Tidying that up, my expression is that, and that is in completing the square form. Expand that out, I get back to the original. Fourth example, x squared, take away 4x, add 18. Try it yourself. X, take away 2 squared, that would expand out to x squared, take away 4x, add 4. So I subtract the 4 to take account of the 4 it's introduced, but I want a plus 18. Now you could do that step all in one go if you wanted. I'm just putting a method down for you to follow. Take away 4, add 18 leads to plus 14. So let's just generalize the steps for this. To complete the square for the expression x squared plus 2ax plus b, we first of all write down x plus a and square it, where the a here is half the coefficient of x in the original expression. We then subtract a squared, that's the number that's introduced when we expand this out. We then add on the b, because that has to be in the expression that we finish up with, and then lastly we just simplify minus a squared add b to get a single number. Let's have a look at another style of question then. Still the same topic, it's just worded slightly different, and this is often the wording in a question at AS. The expression x squared minus 8x add 18 can be written in the form x minus p all squared plus q for all values of x. For those of you that are interested, that's what's referred to as an identity. Find the values of p and q. So without saying it specifically, it's saying complete the square on x squared, take away 8x, add 18. So here we go. X squared, take away 8x, add 18 is x take away 4 squared. Following the steps, we then subtract the 4 squared, or the negative 4 squared, which is 16. And then add on what was there originally, and that gives us x take away 4 squared add 2. So we can say that's identically equal to x take away p squared add q, where p equals 4 and q equals 2. By this point you might be thinking, well, what's the point of that? I'm used to factorising, so why do I need completing the square? So let's look at some uses. Here's one use. Sketching graphs. Let's pick up the example we've just done. Suppose the question says sketch y equals x squared, take away 8x, add 18. From what we've just said, then the right hand side there can be written in this form. Now if you're sketching a graph and it's a quadratic, what you might normally do is try and find the two places or the three places where the curve is going to cross the axes. So you might, as a first approach, try to factorise this and find the two places where y equals 0. In other words, the two places on the x-axis where that crosses. The problem is, with this particular example, it doesn't factorise. So let's have a look at what we've got here. Y equals x take away 4 all squared add 2, so we can say it's the same shape as y equals x squared, but it's been moved 4 to the right and 2 up. So it's the same shape as y equals x squared, translated with vector 4, 2. So it's y equals x squared, shifted 4 to the right and 2 up. So this point here is 4 across and 2 up. And we know it crosses the y-axis when x is 0, so looking back at the original expression, it crosses at 18. Notice another benefit of this format is if the question says what's the lowest point, what's the minimum value of this curve, at A level it might start talking about the range of it, then we can see from this format up here that x take away 4 squared is always going to be bigger than or equal to 0. So the smallest this expression is ever going to get is 0. When x equals 4. So when x equals 4, this whole expression is taking its lowest value, which is plus 2. So again, for the A-level students amongst you, there's a stationary point or a turning point at 4, 2, all without the need to differentiate. If none of those words mean anything to you, then don't worry, it's something you'll meet at A-level. If you've done the IGCSE course from Edexcel, you'll have also come across differentiation and turning points. So in this format we can see very clearly what the smallest value of y is going to be. It's going to be whatever is outside of the squared bracket, and it takes place at the value of x that makes the squared bracket equal to 0. That's one way of using completing the square. Another is to get exact values for quadratic equations. So this will be useful for you at A-level, because with C1 being a non-calculator exam, there needs to be ways of solving things without resorting to calculator. So let's go for x squared add 24x take away 8 equals 0. and you'll see the word exactly coming up. Find exact solutions. So let's go right ahead and complete the square on this. We need an x, add 12 in the bracket. That brings in a 144, so we subtract 144, and we have a subtract 8 as well. So we do that. Tidy that up before we do anything else. That's take away 152 equal to 0. I now add 152 to each side. X plus 12 all squared equals 152. I now square root each side. So x add 12 is going to equal positive or negative root of 152, which in turn, we should always give these in as simple form as possible. So using surd rules that we're familiar with, also in C1, also at A-level, at GCSE, which is the same as plus or minus root 4 root 38, which is plus or minus 2 root 38. I now need to subtract 12 from each side, so my exact values for the solution to this equation are minus 12 plus or minus 2 root 38. Right, just to finish off then, this is for all those of you that have used the quadratic formula at GCSE and were slightly unsatisfied as to why that was the equation. Here's the full story. Complete the square for the general quadratic equation to find the exact solutions. So by the general quadratic equation we mean ax squared plus bx plus c equal to 0. So the first thing I'm going to do is divide by a, seeing as we've just been talking about completing the square where there's just one lot of x squared. That gives us x squared b over a lots of x plus c over a equal to 0. Following the steps that we've been talking about, I put half as much in here for the number as the x coefficient, so that's b over 2a squared. That will bring in a b over 2a multiplied by a b over 2a, so I subtract b squared over 4a squared, and the plus ca is c over a is still there. I now need to move this from here, so I'm going to add b squared over 4a squared and subtract c over a. What I'm now going to do on the right hand side is put this over a common denominator. Well, the common denominator is 4a squared, so the first term stays as it is. The second term needs multiplying by 4a on the top and the bottom. So that gives me b squared over 4a squared, take away 4ac over 4a squared, which is starting to look familiar. The denominators are now the same, so I can write them as a single algebraic fraction. And that's what x plus b over 2a all squared equals. So I now square root each side. And that will give me plus or minus the square root of b squared minus 4ac over 4a squared. Now, according to the rules of surds that we're familiar with, the square root of a fraction is the same as the square root of the top divided by the square root of the bottom. So the top I leave in this form. Square root of 4a squared is 2a. I'm nearly there. And I'm nearly out of room. So I subtract b over 2a from each side. So x will equal minus b over 2a plus or minus square root b squared minus 4ac over 2a. And as with the step up here, they have the same denominator, so I'll turn them into a single fraction. Minus b plus or minus b squared take away 4ac over 2a. The general solution for the quadratic formula. Thank you very much. I hope you found that useful. Let's just, to finish off with, look at a couple of websites that I've referred to before in other tutorials. This is my maths. I've logged on and I'm looking at the lesson. Each topic has got a lesson and then it's got an associated homework, so it's a good way to generate lots of different examples for you to try without having to write too much down. Admittedly, you do need to do a bit of working out on paper occasionally, but it's a good way of getting to grips with a method without doing too much writing. So let's just follow through this animation. I'm not going to read it out, I'll let you do it and put some nice music over it while you read. If I go too fast by clicking the next button, then just pause it, read it, carry on. Lovely. Another website, again, that I've referred to before is Waldo Maths. I've already loaded up the correct version here, and you can see this is the example we were working on before. Waldo Maths it's a Java website, there's lots of little applets, and it very much takes the format of Suck It and See, trying to change variables, seeing how that affects what's going on. So it's not so much as solving problems for every single one, it's trying different things to see how altering numbers affects the shape of graphs or expressions in brackets and whatever else it might be. It covers the whole range. Let me just show you from the main menu. There's an 11 to 16, that's for Key Stage 3 and some of GCSE. 16 to 19 obviously overlaps GCSE and A-level. So let's just pick that one because that's where this one was from. And you can see you get core work, you get probability and stats. So hope you found that useful. See you again another time.